Good afternoon, everyone. 2 o'clock Sec 4 EMath lesson with teacher Jason over here to start the lesson proper. Alright, so just some general rules as usual. Just be patient and understanding, gracious and respectful behavior even in digital space. So when you type certain comments, just be careful. And lastly, ask good and relevant questions for the topic today. So what are we going through? In this case, vectors again, but a lot of recap, so stay tuned for that. Just a little recap. And also something new. So we are going to learn how to scalar multiply vectors, and as well as knowing parallel vectors and what other things that can come about, or even position vectors as well. So let me make a note over here. You're going to learn something known as position vectors. So one thing to take note in addition to all this as well. Alright, so just in case, they are part of parallel vectors, but in this case, quite related. Alright, so let's get it started. So a lot of recap. How do we represent vectors? In this case, a vectors, if you see below, it's a directed line segment. Alright, directed line segment. Okay, so just bear with me, quite a bit of recaps over here. Directed line segment, where in this case, first thing to take note, the length represents the magnitude, the arrow represents the direction. Okay, so let me just recap. Length represents the magnitude, arrow represents the direction. In this case, my vector is going from A to B. I repeat, from A to B. Okay, so how do we represent a vector? In this case, either we bold it, but in this case, you guys will not be able to bold your writing so much, otherwise you will break the paper. So in this case, A to B written as such. So from here, A to B indicated by arrow at the top. Or in this case, if it's a single letter, A with a curly sign. In this case, A with a curly sign. Starting from A, so that's why we call A as the starting point. Or we call it the initial point. And lastly, in this case, B is what we call the ending point. Or in this case, to what we call the terminal point. Alright, so certain things to take note of. And as well as now, knowing a vector as such, how do we draw it on the Cartesian plane? So again, for vectors, it's always two coordinates, or two values, not coordinates, sorry for that, x, y. X represents on the value on the x-axis, y represents the value on the y-axis. So y, y, x, and x-axis as well. So just follow up from there. And also, that is what we need to know on vectors for this particular lesson for today. And now, with this knowledge that we have so far, let's investigate. Given that A is 1, 2, how do we draw the vector 2A? So in this case, when we talk about a vector, okay, 1, 2, over here in this grid, we represent this as 1 unit. Okay, so just take note, 1 unit, 1 unit. So this big square over here as 1 unit. Alright, now what happens if I want to draw 1, 2? So I hope you all realize, okay, 1, 2, 2 times, so 2A. How do I draw this vector 2A? So how we do, we are just going to draw, take note, 1 unit on right, 2 units up. So it's going to be, okay, let me just draw a bit lower. So 1 unit is this way, 2 units up. So 1, 2. So in that way, this is going to be my first vector. Okay, apologies for that. Let me just do some editing. Sorry for that. Let me just include certain stuff. Okay, so first vector. So what do I need to do? Yes. Okay, so my first vector is going to be from here to here. This is A, right? This is my A. So A as such. This is my A. Okay, now if I want to draw 2A, guys, what do you think I should do? Okay, from here, if I want to draw 2A, all I need to do, following the same thing again, because I'm drawing another vector, 1, 2. So following up, it's going to be just none other than me drawing another line from the endpoint of the other vector. Sorry for that. Let me just redraw. Okay, from here, yes. Okay, and this is what I have, another A. So to draw the vector 2A, I'm just drawing the vector twice. Now, what do you realize about this vector 2A? Can anybody tell me for this vector 2A? Over here, in this case, let me highlight 2A. What is the value of this vector 2, 8? Does anybody want to give it a shot? So 2, 8. How do I represent it in my Cartesian form? Very good, Denise. Anybody else wants to try? Good note over here is actually a recap of what we have learned so far. Anybody else wants to try? What is the vector 2, 8? Very good, Zing. Perfect job over there. Okay, so good job. You realize in this case is 2, 4. But in this case, good job, Zing. Alright, very enthusiastic over there. But I realize what I need to do. If I take out the 2 over here, it's actually just 2 times of this vector 8. So what does this mean? Okay, this actually means that if I scalar multiply a matrix, you get a totally new vector by extending it, depending on the amount. So in this case, if I were to do multiplication, in this case, Ka is equal to Kxy. Therefore, I'm just going to get over here, just multiply Kx, Ky over here. Okay, I hope this is not too hard. Okay, so it's similar to matrices, just multiply each of the entries by K. Now let's investigate even further over here. In this case, because there are quite some vectors to draw, so take note, in this case, my 1 unit will be this. Okay, this is my 1 unit long. Okay, it's a different way of writing here. So this is my 1 unit long. And this is my 1 unit long. Okay, let's draw my vector 1, 2, shall we? Okay, 1, 2. So in this case, 1 and 2 units up. So therefore, for A, this will be my vector. And this will be my vector 8. 1, 2. Now, B, 3, 6. I hope you all realize it's just 3 times. So in this case, let's draw my vector 3. So over here, it's going to be 1, 2, 3, and 6 times up. So just bear with me while I draw the dots to coordinate. 1, 2, 3, 4, 5, 6. And again, let me use a different color line, shall we? Let's say, let's use blue. So over here, this is my blue vector. And this is my vector. In this case, let's use the color according to it. Let's say B. And next one, -2, -4. Now take notes, guys. -2 means I'm going 4 units down, 2 units left. So 4 units down, so it's going to be 1. Let me just draw it the other way. So 1, 2, 3, 4, and 2 units left. So I hope you realize in this case, I'm going to draw another vector with a green color line over here. To signify, in this case, it's going to be my vector C. Okay, I hope you all can see the vector over here. Now, what do you notice about these 3 vectors? Is there something you can take note of these vectors over here? Very good, Denise. That's the word I'm looking for, but anybody else wants to try? Doing very well, Denise. Huh? Doing very well, but anybody else wants to try? What's that keyword I'm looking for? What do I notice about these 3 vectors? Okay, in fact, let me give you a hint. They have a particular property over here, if you take a look. Okay, in fact, if you guys are trying to find out, okay, the keyword over here is they are parallel. Okay, but what is this keyword for being parallel, or why are they parallel? Okay, but before I go to that, let's try to express A. You realize, if I were to write it in their Cartesian form, coordinate form, A, it's 1, 2. B, I can write it as 3, 6. But any other way, very good. Okay, Voidner, I think I get what you mean, but yes, they are all of the certain manner. Shayna, yes. Okay, direction-wise, okay, you realize they don't have to follow the same direction because these 2 are pointing up, but 1 is pointing down. Okay, so just take note from there. But good note over there, Shayna. B, you realize I can express as a scalar multiple of another vector. Whereas C over here, -2, -4, I can also express as a scalar multiple of another vector, which in this case, this is my vector. So if you realize they are parallel, and looking into this particular way of representing them, how do I know whether the vectors are parallel instead of drawing them? Because drawing them can be a bit of a hassle. How do I know whether they are parallel? The key concept is here. 2 vectors are parallel if they have the same, in this case, or I would like to add a keyword, it's not really the same, if the same or exactly opposite direction. Okay, it's not just the same, okay? Same direction, if we refer, same direction is this way. The second note is if they have the exactly opposite direction. I said two vectors are parallel, but this is regardless of magnitude. So we realize regardless of how long or short the magnitude is, as long as they follow this same or exactly opposite, okay, exactly opposite guys, exactly opposite direction, then I say they are parallel. And if A and B are non-zero and parallel vectors, I can express one of the vector as what we have gone through in the other math concept as well, as a scalar multiple of the other vector. Okay, B is a scalar multiple of another vector, where you realize in this case, this is A, this is A, which reflects the concept over here. Alright, so I hope you are getting this. Let me just get some feedback to see whether you understand on parallel vectors before I go on to my work example. Okay, over here to make sure you understand accordingly. Okay, that's very nice. If there's a red over there, a little Q&A after this lesson, so feel free to ask me ahead. Alright, that's good to hear, good to see. Okay, I'm seeing more greens. That's good, that's good. Okay, so let me just move on. Anything unclear, just let me know, alright? Now from here, very important to listen to my explanation over here. Okay, when we go through. Yeah, that is right, Fion. In this case, when I factor out certain things, you realize, hey, the ones in the brackets actually follows up to another vector over here. So that's why it's parallel. In this case, back to Fion over here, you realize if factor out A, there is another vector that is the same here. So that's why they're parallel. And it holds true because this is the property of what it means for the vectors to be parallel. I hope I've answered your question correctly, Fion. I mean clearly. Okay? Alright, glad to hear, Fion. Thank you for your response. Now, following up. First up, given these vectors, how do I solve for my vectors? First one, straightforward, 3a minus 2b. Just be careful of your scalar multiplication. So 3, a recap of your matrices, negative 1, 4, minus 2, negative 3, 1. Okay, simplify. This will just give you 3, negative 12, minus 6, minus 1. Sorry, not minus 1, minus 2. Okay, simplify further. I'm going to get minus 3, minus 10. Yes, minus 3, minus 10 over here. Okay, minus 3, minus 10. That is what I'm going to get. Okay, next up. Now, the value of m if 2a is equals to b plus half c. Again, following your matrix multiplication, scalar multiplication, just take note. So it's going to be 2a is equals to b plus half c. Just take note of your scalar multiplication. Okay, a, copy your vector down. Did I copy my vector wrongly? 2a, 1 minus 3, 1. Yes. No, it's correct. Okay, so equals to b, negative 3, 1 plus half of c. Okay, so from here it's a scalar multiplication. So just take note from there. Be very careful. Okay, again, no space. So let me write another line. So that's where I have 2, negative 8 is equals to 3, 1. Plus, in this case, just multiply my constants in half m, negative 7. So henceforth, it should be the same. If you realize they are the same, 2, negative 8. This is equals to 3 plus half m and negative 8. Now from here to find the value of m, if they are equal, you realize what can I do is, I can just do this. And from here, I can solve for the value of m. Half m is equals to minus 1. M is therefore equals to minus 2. So therefore, again, just follow your scalar multiplication. Now, how do I then solve for C? So we call A is parallel to D. So what is the first equation I can form? I'll give you all some time to think about it. What's the first equation I can think of when they are parallel? I'll give you some time to think about it. What's the first equation I can form? Alright, give you some time. Very good. So you realize if okay, Jude, for this one, it's a line. But over here, I'm talking about vector. Yep, you can sub out. That's right. Very good, Denise. That's actually correct over here. Let me just take a look. Okay. Yep, you can do that as well, but there should not be a constant over there. Take note, there should not be a constant. Okay, what do I mean? Because we're talking about parallel lines. Jude, for that one, is actually just a straight line. Okay, over here, vectors, we talk about direction, so we need to know of a certain thing. So we call, take note, A is parallel to D. So what we want to do, A is a scalar multiple of D. So when we talk about parallel vectors, take note, we write this statement down first. Very important. Once we write this statement down, you realize, or take note, for those who say, can I write it the other way? Also can, doesn't matter. As long as one of them is a scalar multiple of the other. It doesn't matter. Both are okay. Yeah, I'm seeing a good response from you, saying that's good. Okay. Denise, in this case, just take note, there should not be a constant there. Just write it as such. But in this case, I'm following for the one in black. So it's the same thing. Okay. So take note, you wrote 4, 1 minus 4, right? There should not be a 4 there. Okay. It should be a general constant over here. It should be a number. It should be a variable. Okay. You don't write a constant. Okay. In this case, when yeah, but if you factor out, which one do you factor out? 4, 1 minus 4. Let me take a look. D is 8n. Okay. A is, take note, if you factor out 4, it's the different vector. Ah, yes. Okay. Yeah, if you take note, it's a different vector. Okay. So what you do, no worries, Denise. In this case, just write the vector down. 1, negative 4 is equals to K 8n. But then you realize, if I were to write this down, I cannot really solve. Because why? I'm going to have, okay, 8k is equals to 1. And I have the other equation, nk equals to 4. But the question wants me to solve for k. So what should I do first? Okay, no worries. Okay, I'll write the other side. Okay, both of the same thing, but I'll write the other side to make things clearer. So in this case, what can I do over here? 1 is equals to 8k and negative 4 is equals to nk. So guys, what do you think I can do first? No worries, Denise. In this case, the other equation, take note. Okay, I hope I've written what you desire. So take note over here. You realize, if I were to do this, yeah, both are correct because they are parallel, but in this case, we're just representing in the scalar multiple. So just take note from there. All right, in this case, if you were to realize, guys, if I were to solve for k first, because the other one has 2 variables. So what we want to do, we want to convert one of the equations such that we are only solving for 1 variable. So k, in this case, if you solve for 1, it's 1 over 8. Solving from here. And once you have this, my second equation becomes, I have 1 over 8, n is equals to minus 4, and therefore, n is equals to 32, which you realize over here. Okay, so that's how we actually solve for such questions, starting from the statement where the 2 vectors are parallel. If you solve it both other ways, you will still get the same answer. Okay, now, time for you all to try. First one, it shouldn't take you too long, that's why it's 30 seconds. Because what happens is, when I talk about scalar multiples, let me just go back to that. When I talk about scalar multiples, Denise, okay, it is just saying that, if you refer to this slide, both are scalar multiple of each other, right? But if I say in this case, B is 3 times of A, or in this case, A is 1 over 2, which I can represent it as 1 over 3 times 3 over 6. Isn't it also a scalar multiple? So that's why in this case, both are okay. They are just a scalar multiple. Just that the multiple is different. It's fine. Okay, so you can take note from there. Alright, it doesn't have to be correct. My scalar multiple just have to signify that both of the vectors are parallel. Or in this case, If you were to write it, you can say B is some constant of A. Both are okay. Yeah, that's right, K and B are different. Is this clear now, Denise? Alright. If not, I hope you understand. Launching this bubble launcher for this one, it should be clear in 3, 2, 1. Let's go. Okay. Take some time. I want 2y minus x. So what do I have? 2y minus x. Okay, so quickly write down a response. Okay, 2y minus x. Alright, very good. So 2y. So what is my vector 2? So I have 2, 18, 12 minus x. So take note, identify my correct vector. So solving it, what do I have? Very nice. Doing good. Yes, that's right. The case can be different for both equations. Yes, it can be different. Yeah, depending on which one you express as a scalar multiple of, very important. Okay, just be very careful. Take note of the errors that it carries forward. Okay, along the way, ask me the questions. I'll be more than happy to answer your queries along the way. Okay, last 3. Okay, doing good. Okay, most of you got it correct, but just take note. Over here, just take note of the scalar multiplication, 36, 24 minus 6, 8. Okay, take note of the minus sign. It should be a negative 30 and 6. Okay, so it's not 42, it's going to be negative 30, and in this case, not 6, 16. You just simplify correctly from there, and that's why question 4 is the answer. No worries, Denise. Okay, glad that you are clear. Don't worry about it. That's where we clarify. Okay, next up from here, making use of parallel. Again, same thing over here. If they are parallel, what can we do? Launching the bubble launcher again. What is the equation you can form in 3, 2, 1? Let's go. Okay, take some steps. What does it mean to be parallel? Alright, getting the answer down. Very good. Okay, what do we have over here? Last 40 seconds. Alright, so when it's parallel, take note what should we have. Alright, that's very, very nice. Take note of the vectors that are parallel to each other, yeah? Okay, that's why. Okay, I think I need to go through this. Take note, I'm looking for the value of P. What does it mean? Okay, last 10 seconds. Alright, I would say most of you got it. Last 3. Okay, most of you got it, but some of you need some time, so let me go through. Y is parallel to Z. So there are 2 ways you can write it. One, Y is equals to KZ. Or Z is equals to Q of Y. But in this case, I will just follow this one first. Okay, the other one you can decipher. You should get the same value. Take note, ultimately, we are not solving for the value of K. We want the value of P. So when we solve this from here, we have negative 18, 12 equals to K of P. Negative 3, sorry for that. Negative 3. From here, I have a negative 18, PK, and the other equation, negative 3K is equals to 12. Now, PK, I cannot solve for P yet. I hope you all realize from here. I solve for K first before I solve for P, which in this case is 4.5. So take note, just remember from parallel, that's how I got answer number 3. Alright, all good? Okay. I hope it's good. Let me just initiate feedback to check whether it's clear before I move on to more topic recaps over here for the next few concepts. Alright, seems like it's a good sign. That's good to hear. Okay, so from here, let me carry on. In this case, I think it's all good. Most of the responses are there. Addition of column vectors, very similar to your matrices. If I add, both of my entries has to be added. Okay, P plus X, Q plus Y. And in this case, if I were to subtract, I'm subtracting both entries. Alright, pretty straightforward over here. both entries over here. Right now, because of this, what happens? Okay, I cannot really check whether you understand the drawing of vectors. So the next bubble question will be to recap. How do we actually draw vectors? Now take a close look at what these vectors are actually asking. Okay, this is to actually ask, given these two vectors, which vector makes sense to draw 2a minus 2b? This is your vector A, this is your vector B. What is the resulting vector 2a minus 2b? Let's recap a little bit. Okay, launching the bubble launcher very soon in 3. Take note, this is my vector A, this is my vector B. How do I draw? 2a minus 2b. Okay, launching the bubble launcher in 3, 2, 1. Okay, this is a bit visualization, so I'm going to give you some time to see before I launch it for you. It's going to be a little bit hard to visualize, so take a close look. Okay, and in fact, if you realize, there are some of the options I can eliminate straight away already. Okay, so don't worry, this is a little hard for visualization. I understand, it's quite a hard question. Okay, so take note, this is vector A, this is vector B. What is 2a minus 2b? Which vector looks like it? Okay, this is quite a hard question, I would agree. Last 20 seconds, give it a shot. Okay, I'll go through this. Okay, for this one, again, it goes by elimination, so it's a little bit hard to see, so don't worry about it. Okay, there are different representations of 2a minus 2b. Alright, so I will explain this accordingly. Okay, last 5, 4, 3, 2, 1. Okay, don't worry, I explain this again. Okay, again, this is hard to see, but that's where we visualize. Okay, it's hard to see. First one, you realize number 2, it's not correct. Why is it not correct? Because if I have to draw it, A, it's 1, 2, 3, and 1. So you visualize, A in this case is 1, 2, 3, followed up by 1. So you look at A, it's actually 2 of A. So that's why it's not correct. This is actually 2A. Because it's A here, A here. And if you were to do 4, in this case, it's B. Because it's 2 out, 1 down. So follow 1, 2, 1, 1, 2, 1. This is going B, B. So that's why it's 2B. Now, you realize for 3, the difference between 1 and 3, how do I see? If you take a close look, this is a bit hard to see. Okay, it's not really a trend over here. So 1, 2, 3, 1, 1, 2, 1. So this is actually following A, B over here. And then if I follow another one, if I can follow B, because it's going to be 1, 2, 1, 1, 2. And then sorry for that. Okay, and then if I go 1, 2, 3, 1, so that's why it's up. And as such. So that's how you visualize the vector. Right. You can use that method as well, don't worry about it, but it's just different ways of visualizing how the vector is drawn. You can use that method as well. Yes, that is actually correct. You can use that method as well. So by elimination, you realize 2a plus 2b. Okay, so by elimination, you realize it's 1. And how does 1 look like 2a minus 2b? Okay, so you realize it's a bit hard to see. So if we start here, 1, 2, 3, and 1. This is my A. And then from there, if I have to draw B, but in this case, take note, I want minus B. So minus B is actually 1 up, 2 left. So 1 up, 2 left. Minus B. And then, yep, that's right, it should be horizontal. But again, this vector is a bit hard to draw, so we visualize from here. So again, 1 up, 2 left. 1 up, 2 left. Minus B. And in this case, going for A, 1, 2, 3, up. So 1 up, 1, 2, 3, A over here. Alright, again, this vector, I agree, is a bit hard to draw, but don't worry, it's just for visualization. There are many different ways of drawing 2a minus 2b, but this is just one particular way of doing it. Alright, so don't worry about it, guys. It's just mainly a recap, and hopefully you understand better from that. Okay, now, work example 2. How do I express this vector AB in terms of a and b? Okay, now, just now is given these vectors. I ask you how to draw this. I ask you to draw the resultant. Now for this one, is given the resultant vector. How do I draw or represent it in A and B? So let's visualize. I want A and B. So what do? I want this direction. Okay, again, so for drawing, you actually have to recap and see how we visualize this accordingly as such. So now, let's visualize how we go through this. Okay, A over here is 1, 2, 3, or 3 units forward and 1 unit up. B, again following the same thing, is 2 out, 1 down. So take note of the units that we are representing here. From A to B, how do we actually draw this? So a resulting vector, let's visualize for A how much we have. We have 1, 2, 3, 4, 5, 6, 7, 8, and 1 up. Okay, so we can use actually the boxes over here to identify what is my A, what is my B. So A is like 8 forward, 1 up. Okay, so how do we visualize this? Okay, first things first, we need the vector to go forward and up first, right? Okay, because the vector is going up somehow. So maybe let's draw A 2 times and see what happens. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's draw A 2 times and see what happens. So A, if I were to draw 2 times, it's going to be 6 forward, 2 up. Okay, so let's draw first. So 6 forward, 2 up. So 6 forward. So how would I draw this? It's going to be 6 forward, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then let me draw 1, 2 up. So 2A should be here. Okay, I hope you all can visualize. Let me just use my line over here. 2A. But now you realize from here 2A go up already. What is my next vector I should draw to give me AB? Write down your answers. What is my next vector I should draw to give me AB? What is the next vector I should draw here? Okay. You realize what is my B vector? B vector is 2, 1. So if I visualize, 2, 1. Do you all agree drawing it down this way will give me my vector AB, and henceforth, taking note over here, AB. How do I express these vectors in terms of A and B? Write down answers. How do I express this vector in terms of A and B? Give us some time, think about it. I have 2A. Okay, it's not multiply, Royden. Take note, I'm adding my vectors up, but you're close, you're getting there. 2 of A and B. To get to that. Yep, that's right, 8, 1. But in terms of A and B, I want A and B. I want the alphabets only, A and B. I don't want numbers, alphabets. I want the alphabets involved in this. Okay, there's 2 of A and 1 of B. So what do I do when I add vectors? I add to their direction. Very good, Denise. That's the answer. Anybody else wants to try? Okay, so you realize 2 of A and 1 of B. That is how I do it. And let me just draw it out. This is my B. With my vector over here. Okay, so that's how I visualize. Any questions, any queries? I think for this one it's going to be tough. So let me initiate the feedback to see whether you roughly understand. Okay, so it's roughly there. Understanding visualization is hard. So you actually have to understand, how do I make use of these vectors to actually draw out my vector over here? How do I visualize? In this case, the different combinations may be a bit hard to see. But one way to think about it, okay, my vector is going up, so how do I make sure my vector goes up? And consider the opposite directions as well. Okay, if you start from B, in this case, okay, if I were to start from B, now if I visualize, if I start from B, my vector is now then going down. Okay, wait, let me erase all this. Okay, maybe for Denise, I'll answer this in the Q&A because I got quite some to cover. I'll answer that back in the Q&A right after this, alright? Okay? Alright, thank you for the reminder, Denise. Now, let's try bubble question 4 to see whether you all can answer. I understand it's a bit hard. So that's why it's 1 minute. Launching the bubble launcher. Give it some time. Visualization is always hard. In 3, 2, 1. Give it a shot for this, avoidant. I'll explain to you later on with this example. Okay, in this case. CD. Let's see how you visualize. Okay? Again, take note of what my vector here is. This is 1 to the left, 1, 2, 3 up. Okay, try to visualize. It's 1 to the left, 1, 2, 3 up. What do we have? And take note, in this case, I want 3 up. So what are my vectors doing? So I need to make sure my vector only goes up, but B is going down. So what can I do? Okay. Okay, I'll use this example to answer you, Royden. If not, there's a Q&A. I'll answer you all later. Okay, let me see the response times up. Okay, seems like I need to go through this. Okay, so how do I actually draw my vector CD? So let's take a look. My vector needs to go up, right? Go up 3 times. One distinctive thing to take note. So to go up 3 times, what it means is this. 1, 2, 3. And it needs to go up. So what happens? Definitely my B cannot go down, so I need it to go up. So what happens? Let's just draw A 1 time first, see what happens. Okay? Because it is 3 times. Okay? A is the 1. Let me go up 1 time first. So A, 1, 2, 3. And it goes up 1 time. But I realize, oh, okay, it has gone up 1, but it's deviating away. So let's check. Okay, right now I need the vectors to go up. And the only way to do it is minus B. Because minus B, switch the direction and it goes up. So therefore, minus B is going to be 2 to the left and 1 unit up. So 1 unit up and 2 to the left. Minus B. And again, following the same thing, 1 unit up, 2 to the left. And that's how we get the vector, in this case, 2B minus A. Is it A minus 2B? Sorry for the A minus 2B. And that is the answer from that. So from here, you have to visualize, in this case, the distinctive features. 1, in this case, my vector is always going up. So what do? Try to make the vector go up and try to see what are the different combinations for you to get to A. And for this one, why is it 2A? Because it is moving quite a bit over here. So I want to see how much can I do to make sure it moves here. Okay, because it's going up, so I want to make sure my vector goes up, so I make use of the different combinations. Okay, this one is a little bit hard, so it requires quite some visualizations along the way. Okay, so for this, if you are still unsure, there's a little Q&A. I'll try to answer as best as I can to make sure how you draw these vectors. Otherwise, try to review this recording to see how you understand from there. Okay, right? Now, let's understand position vectors. So if I were to understand this, okay, position vectors just represents like a coordinate, represents the positions of these vectors. So column vector, my coordinate here is 2, 5. So how do I represent this column vector OA? Anybody else want to try? How do I represent it in my form? How do I represent this vector OA? Okay, OA means I want the vector to start from O and go to A. So how do I represent this vector OA? Give it some try, think about it. Okay, very nice. So you realize what I perceive. Very good, Denise. That's actually the answer. Anybody else wants to try? OA. Because it starts from O, I want it to go to A. Jude, give you another try. You are giving me the other one. I want OA. A is here. So if you take a look, OA, yeah, that's right. So take a look. O, it's 2 units forward, 5 units up. So that's why in this case it's OA. Where in this case you realize it's 2, 5. Okay, now June has actually answered for me B, so I'll go through that. B is in this case 3 at the opposite side. So 1, 2, 3 and 1 unit up. So in this case, this vector is going to represent my 3, 1, negative 3, 1 to be exact. So that's my vector, negative 3, 1. Now you realize in this case, okay, how do I then represent my vector AB? So how do I find AB? So AB, were to realize, is actually, do you agree, going from A to O and O to B? Because that's AB. Let's visualize. AB. Okay, AB can be drawn as going from A to O and O to B. But I only know OA. So you realize if I can switch it around, minus OA plus OB is actually OA minus OB minus OA. And then if you want to simplify it, and take a look at the trend. B, A. And in this case, B and A. So if I can simplify it, you realize OB minus OA is none other than negative 3, 1 minus 2, 5. In fact, you can try, it's actually minus 5 and 4. Minus 5 and minus 4, which is correct because you realize it's going 1, 2, 3, 4, 5 units to the left and 1, 2, 3, 4 units down, which is essentially the vector minus 5, 4. So what do you see the trend here? The trend is this. Okay, what's the column vector AB, which is what I've gone through just now? Over here, sorry for that. This one should be over here. Sorry for that, I missed that out. But essentially what I've gone through just now is this. In general, if I have my position vector A has these coordinates. It's going to be X, Y. Okay, just draw it column wise. And the notion is, okay, if you use the triangle law, just now what I've done, AB, if you follow the trend just now, it's going to be B and A. So it's going to be OB. Second letter minus first letter. Very interesting note over here. You realize this is going to be just second letter minus first letter. That's a try I always like to use. Second letter minus first letter. Okay, so that is one thing that we can take note of. Now, how would I then solve this? Okay, so how do I summarize in this case? Let's use this example to summarize for you. Okay, BC. So how do I solve BC? BC, if we use the column vector method, I always say it's going to be OC minus OB. C and B over here. OC minus OB. Once you know this, what happens? It's going to be negative 2, 6, 2, negative 6, sorry, minus 10, minus 8. Simplify more, I'm going to get 12 and 2. Okay, straightforward. B, C, A. What do I have? It's going to be second letter, first letter. So what do? I do OA minus OC. So again, second letter minus first letter. And that's how I do it. Once you know these vectors, you realize you don't have to convert anything. It's quite confusing because you have to multiply by a negative sign. OA is going to be 7, 3, minus OC, which is 2, negative 6. This gives me subtracting 5 and 9. Okay, so this is actually the trend to solve for my column vectors using position vectors over here. Alright, making sense over here? Let me just initiate my feedback to see whether you understand this work example before I move on to the next one. Okay, so it's half, roughly understand. Yes, it's always O. Yep, that's right. Okay, so for those who are always in the red, just let me know whether you understand clearly, okay? Okay, that's good. I will move on to the next work example over here. That's why you realize certain questions can come about position and parallel vectors. This is one example. Now, column vector AB. AB follow the trend, second letter minus first letter. OB minus OA. In this case, it's going to be 2, negative 6, minus 1, 2. Simplify further. Negative 3, negative 8. From here, now, AB is equals to 3AC. So realize what I need to do. I don't know what is C. So therefore, we use the trick. Let C be some coordinate XY. Take note they want coordinate here. So therefore, I want to find AC. Because I know AB, but I don't know AC. So I need to find the vector AC. So AC in this case is OC minus OA. Second letter minus first letter. XY minus negative 1, 2. This gives me X plus 1, Y minus 2. From there, they already tell you AB is 3AC. So what do I have? Write it down. AB is equals to 3AC. What is AB? AB from part A. 3, negative 8. For finding OB. Nope, you cannot because it's from A to B. OA minus OB. If I draw OA, let's say OA is here. OB is here, Jude. OA minus OB. Am I getting any vector? Minus OB is in fact the other direction. So the vector you are getting is actually BA, not AB. Is that clear, Jude? So in this case, that's why in this case, if I use OA minus OB, you are getting BA. Because what you're always doing, when you're doing this notion over here, it's always second letter minus first letter. Okay? Again, following the trend, second letter minus the first letter. Okay? Once you follow up from that, very good note over here. Realize when we solve 3AC. AC, X plus 1, Y minus 2. That's where you can solve the different coordinates because I have 3, 8, and all you need to do, you are just solving for my different coordinates over here. 3y minus 6. Solving it, you're going to get 3x plus 3. I'll go 3 with you, Denise, during the Q&A later. Equals to 3. 3y minus 6 equals to minus 8. Okay, so I have 3x is equals to 0. X is equals to 0. 3y is equals to minus 2. Y is equals to minus 2 over 3. Henceforth, take note, they want coordinates. So summarize for them. C is 0 and minus 2 over 3. Alright, makes sense? Alright, I hope this is clear because let's simplify for bubble question 5. Launching the bubble launcher in 3, 2, 1, and let's go. So I want PQ, so how do I do it? Okay, if you follow my notion over here, it should be quite clear over here, alright? Yeah, that's good. So remember, what is PQ? PQ is going to be, and how would I solve? Okay, very good. Last 15 seconds. Okay, for those who understand this, second letter minus first letter. How do I do it? Last 3, 2, 1. Alright, time's up. Okay, so not too bad, most of you got it, but let me just summarize. In this case, minus 4, minus 6, minus 2, 1, and that's where I have minus 6, minus 7. That is P cubed. Right, that's why answer is 2 over here. Now next one, what would I have? From A, you have this vector. How would I solve for the coordinates of R? Okay, so for this one, what happens is, coordinates of R. How would I solve this? Remember, R, if you are not sure, always remember you let R be xy. First thing. And how would I solve them now? Launching the bubble launcher, alright, in 3, 2, 1, and let's go. You have 1 minute 30 seconds, let's do this together, alright? Okay, remember this exact same question is the same way of how I would do it, okay? First step, what must you do first? You realize, take note, this is given as QP. There's a catch here, it's given as QP, not PQ. Alright, give you some time, alright, give yourself some time, you can do this, alright, hang in there. Last 50 seconds. Alright, I have my first answer here, so take note, first step that you need to do. Alright, that's good, that's good. Launching right now, last 30 seconds. So I hope you all realize you need to find PR. What is PR? PR is second letter minus first letter. Alright, that's good. I'm seeing the responses here. Last 10 seconds. Alright, last 5. You have a mixture of 2 responses. Okay. Okay, seems like the rest of you all just smash the button, yeah? Okay, let's take note. Let's see how we solve. OR minus OP. X, Y minus, in this case, 2, 1. So what will I get? I'll get X minus 2, Y minus 1. So from here, I want QP. Now take note, PQ is this. So QP, it's the opposite direction, if you were to realize from the previous lessons you have. So minus 6 minus 7, this gives me 6, 7. So therefore, QP equals to 2R. What will I have? QP is equals to 2PR. What will I have? I'll have 6, 7. Let me just simplify. Equals to 2 of X minus 2, Y minus 1. Simplify further. What do I have? I'm going to have 6, 7. This is equals to 2x minus 4 to y minus 2. Alright, what will this simplify to be? In fact, this is just none other than 2x minus 4 equals to 6. 2x is equals to 10. X is equals to 5. X is equals to 5. Yes, and if you realize you have to solve this, you know that this is my answer already. But let's double check for y. 2y minus 2 is equals to 7. 2y is equals to 9. Y is equals to 4.5. That's why 4 is the answer. Okay, so from here, just be clear with your column vectors. Just remember second letter minus first letter. And for those, I will explain it a little bit more in Q&A. Okay, so now we know position vectors, we know parallel vectors. But there's one particular concept that we need to go through when we go through parallel. And that is if my points are collinear. So what do I mean when my points are collinear over here? Okay, let's see. So when I talk about collinear points, let's visualize. Okay, collinear basically means if I draw a line, they lie on the same straight line. So how do I prove them? If I take my vector AB, suppose the line is split into 1, 2. Okay, there are a few different situations. If I have my vector AB, okay, you realize AB in this case is half of BC. I take BC, I cut it into half. It's actually my A vector. So what does it mean? you realize if AB is half of BC, they are parallel because scalar multiple of each other. Let's recap. We have done this before. Scalar multiple of each other. They are parallel. So what do we do? Okay. Take note. Two vectors are parallel and they have a common point. Common point and they are parallel. They are collinear. So that's one thing to take note. As long as you can prove that they are parallel and they are collinear, that means they share one point. That is the notion of being collinear. One common point and parallel to each other. So the other two animations, hope you can visualize that same thing. If I have a vector AC, okay, and it's 1/3 and they are parallel to each other, as the animation suggests, I cut it out. And this is my vector. You realize again, if they are scalar multiple of each other and they are parallel and they have a common point A. And following that, collinear if they have a common point and a k value. This k value can be different if you realize. One last one for the different k value. In this case, I have BC equals 2/3 of AC. So different ways of visualizing it. BC equals to AC. As I have 3, I cut it, left 2 units. And in this case, C is a common point. And following that, the common point is C. So what does this animation tells us over here? Is it tells us that if I have, say, I'll use one relation, AB is equals to KBC, say for example. Okay, K is a constant and has to be non-zero. I say they are collinear. And can anybody tell me in this case, what is the common point over here I can use to say that they are collinear? Anybody else wants to try? What's the common point here I can say? What's the common point I'm using here, guys? That's right. Very good, Denise. Very good, Jude. B is the common point. So that's where I can say it's collinear. And one example over here. Now, find the coordinates of B. So this is inverse. So what we do, use your column vectors. AB is equals to OB minus OA. Now, I do not know what's OB, so what do? I actually write it out as, in this case, just leave OB blank. Fill in what you know. -4, -8 equals to OB minus OA. In this case, -1 and 6. So realize OB is going to be -4, -8 plus -1 and 6. This is -5 and -2. This is my OB. Following up further, they give you C as this point. Okay, so what happens? B. Okay, part B. BC. Again, following that, it's going to be just OC minus OB. Second letter minus first letter. Once you get this down, it's okay. And then you just carry on. OC minus OB. Sorry, OB. OB, it's -5, -2. Okay, so I have -5, -2. So that's going to be 6, 5. And then you realize BD. Following the same notion, OD minus OB. So that's going to be, in this case, 7, 8 minus -5 minus 2, 12, 10. That is what I have over here. Now, considering this, if I were to write down two facts about BC and D, let's take a look at this. If I look at BC and BD, what do I notice? BC and BD. What is one distinctive feature I can visualize? They are parallel. That's good note to take note, Denise. Anybody else wants to try? What else can I say besides being parallel? Because I can write BD as 12, 10, which is 2 of 6, 5. We try to write the constant as a whole value, easier to see. And this is actually 2 of BC. And since they are parallel, and what do you notice? What's the common point here? What's the common point over here? I can take note, where in this case my K It's 2. Don't worry, I'll make myself disappear. Yes, B is the common point, so therefore they are collinear. So if K is a constant, what happens? You realize, and K is non-zero, take note, K is non-zero. In this case, I have points B, C, and D are collinear. But in this case, my common point is going to be B. Okay, you have to take note and show that B is a common point. In this case, let me just make myself disappear so you can see it clearly. Where is my... Is it this one? Yes, okay. So these are the few things to take note. I disappear for all, don't worry, but I just want to tell you, these are the few things to take note. You have to show me that BD is parallel, where K is a constant and non-zero. B is a common point, and to show that they are collinear. Okay? And to solve this question, okay, what to do? Visualize it, try it yourself. So give it a try. This concept actually illustrates what I've gone through for collinear. And to conclude, how do you prove it? Similar as well, example 5. So if you want to solve this, review work example 5 again for this question. And that is actually it for today. Alright, so there's quite a bit over here. So how do we know scalar multiplication? How does it lead to parallel vectors? And how does position vectors actually work to solve them? Alright, so that's actually it for today. Thank you for coming for this lesson. I hope it is clear for you all. Stay tuned for next week. And if there's any questions to ask, there's a Q&A short one. I will try to answer as much questions as possible for this. Until then, stay clear, stay safe. I'll see you all in 2 weeks. Next week, there's no lesson, so 2 weeks time. Alright, take care, stay safe. Bye-bye.